and I need to do more. And I see your glass has been replenished, and I can see you're doing very well. And maybe you need it as you're presenting it. Okay, I'll leave it on to you. I look forward to the second one. By the way, the second session is about sleep and about longevity. Okay, I might have a question about that at the end. We'll see how you go. All yours.
And I neglected to tell you that feel free to get up and stand anytime you want to. Because remember, 50% of brains learn best when they are standing or moving. I tell you, it's real. So feel free to do that anytime you want. When you stand up, even if you don't move after you stood up, you have a 20% increased blood flow to your brain. And if it is fluid enough to get there, it's going to help you. All right. This presentation I did for the very first time just a week ago at Avondale. So let's see how it goes. And if you thought dehydration was important, just you wait. Henry Higgins, just you wait. So I love this quotation. Sleep is the interest we have to pay on the capital which is called in a death. And the higher the rate of interest and the more regularly it is paid, the further the date of redemption is postponed. All that said is an elegant way of sleep is independently linked with longevity. You may be doing lots of other good things, but if you do not get the sleep your brain needs, it will shorten your life. In fact, one of the research projects said if you lose 1 hour a day, you will significantly decrease the length of time you live. I was talking about this at a parent-teacher conference, and a man said, you know the saying, I slept like a baby last night? He said, anyone who says that doesn't have one. And so there are times in life when we perhaps don't get what we need. All right, let's go. So what is sleep? It is not a coma. Because when you're in a coma, you really can't be roused. So sleep is a partially conscious, reversible state from which you can be aroused by stimulation. Now, it depends where you are in the sleep cycle. Sometimes it's harder to arouse a person from sleep than others, but you can be aroused because the environmental stimuli, sound, smells, and physical sensations are lowered, but they're not completely blocked. That's why you can be sound asleep and the phone rings and you're instantly awake. But sleep is really complicated and way more than we thought it was now that we have brain scanning equipment. Most people, if they're healthy, will spend approximately a third of your life sleeping. A little bit less if you sleep 7 hours a night, a little bit more if you sleep 9 like I do. My brain needs 9 hours. And it took me a while to realize that and believe it. Because I used to think, man, 9 hours. All right, that's only going to leave me, what, 15 hours, something like that? Boy, if I sleep just 8, I'll have a whole extra hour to work. Well, I have an extra hour, but I never get as much done as accurately as I do when I've had 9 hours sleep. And so finally I've realized, Arlene, get with the program. So here we have the cutaway of the brain again. And as I said, dehydration affects the whole brain. Well, sleep is connected with the whole brain. For example, the brain stem, it's got something called the reticular activating system, and that stimulates the brain to wake up and stay awake. And you have to block that reticular activating system in order to even fall asleep. The thalamus, which is located between the reptilian and the mammalian layer, these first two subconscious layers, has a group of cells that researchers call the sleep-on cells. And those sleep-on cells can actually block the RAS down here and block the cortex to let you fall asleep. And if that's not working, you're not going to fall asleep. The hypothalamus, which is up here in the top area of the mammalian layer, has your master circadian clock. Everything changed after the Second World War. Up until the Second World War, especially in agricultural parts of the country, when the sun set, not too long after that, people would go to bed. And when the sun came up, they'd wake up. And then we got electric lights, and we had them all over the place, and then we got electronic equipment. And the circadian clock is not followed anymore. And the more closely you can follow it, the better you will sleep. We probably will never follow it exactly like used to happen, but we can do some things. Now, your brain does not rest during sleep. Remember that. You are not sleeping to rest your brain. You are sleeping to give your brain time to do hundreds of housekeeping tasks in your brain and body that if they don't get done, they're going to negatively impact you. Some parts of the brain are even more wide awake, if you will, while you're sleeping than they are while you're awake. There are some functions, fortunately, that continue: breathing, heart rate, blood pressure. But anything that the brain and body consider non-critical, non-essential, kind of gets suppressed, with one exception. If you eat just before you go to bed, you're sunk. Meaning, it's going to probably take, on average, 6 hours to get the food you ate out of your stomach. But then it's got another 16 hours to go through your intestines. And that digestive system is working all the time, and it's connected to the vagus nerve that goes straight to your brain, and it can be very, very difficult to fall asleep. Now, I personally, when I am able, occasionally when I'm traveling it doesn't work very well, but I personally eat, and I'm retired from Adventist Health System, so it's wonderful. I can control my schedule a little better. I personally like to get up and exercise, work for a couple of hours, eat brunch about 10, keep working, eat my second meal about 3:30 or 4, sleep like a baby. Of course, I don't have a baby, but you know what I mean. Now, because largely of the invention of equipment like electroencephalography and polysomnography, we know more about sleep now than we've learned in the previous, 6,000 X number of years. So it's pretty exciting now when we're looking at what sleep does. The brain generates two types of brain waves. I'm not going to go into these. You can look it up on the internet if you want more detail. And together they form one sleep cycle. So you'll have what's called slow wave or non-rapid eye movements. That's NREM. And that's characterized by really deep sleep and slow waves. And most people start the sleep cycle in non-REM. And that's when the brain really hits some of the most important housekeeping tasks. And the research shows that if you can get to bed by 10 at the latest and get 2 hours of good sleep before midnight, the brain is able to accomplish many of those complex housekeeping tasks much easier than if you stay up late, even if you slept 8 or 9 hours after midnight. Now that was a struggle for me, because I thought that I did my best work, all my thesis, dissertations, all of that stuff, from about 11 to 4 in the morning. Well, my brain did seem to be very alert then, but when I got this research, I decided to change. I'm in bed most of the time by 9:30 if I can, or by 10, and I'm telling you, I am wide awake without an alarm by 6, and my brain actually works in the morning. I think it works better than it used to, but I had to retrain it. Then we go into something called rapid eye movement, REM sleep, and that's where we dream. And dreaming is believed to be very good for us, whether or not you remember your dreams. Some people say, I never dream. Well, if they never dream, they're probably not all that healthy. But they may dream and have no recollection. If you wake up and you remember that you had a dream, you have between 10 and 20 seconds to grab a pencil and start writing down your dream, or do something to remember it, or your brain will not give it back to you. It'll say, look, I told you you dreamed last night. You were not interested. I'm not giving it to you again. Tough turkey. So if there is sleep deprivation and you're really, really, really tired and you finally go to bed, you don't necessarily spend a longer time in that non-REM sleep cycle, but the intensity of what happens during that cycle increases, which is kind of fascinating. So all humans typically begin their sleep cycle with this slow wave non-REM sleep. And during an 8-hour period, the average adult will go through 5 or 6 90 to 110 minute cycles. They'll just follow one on top of each other. And for the people who are listening to this but can't see it, I'm trying to point out some of the information on the slides, just in case you're wondering the reason I'm doing that. So newborns, 16 to 18 hours a day, and it's 50-50, non-REM and REM sleep. But as you get older, the REM sleep declines. The non-REM doesn't, but the REM sleep declines. By the time you hit puberty, it's 25% of your total sleep time, and by the time you get into adulthood, it's a fifth, 20% of your sleep time, and nobody is sure the reason for that. Children 7 to puberty need at least 8 hours of sleep a night. They often do not get this because well-meaning but unenlightened parents do not want to be parents. Their kid says, I want to stay up and watch TV tonight till 11 o'clock. Well, tomorrow's a school day. I know, Mom, but I'll do fine. Okay. They do not do fine. Teenagers need more than children age 7 to puberty. Minimum of 9, many times 10. But statistically, they get 7 or 8. There's a lot going on around puberty and after that. The brain is getting actually rewired. So imagine you're living in your house and the electricians are there rewiring the whole house while you're living there. So it's no wonder that, they have a little trouble. And for some reason, some teenagers develop what's called a delayed sleep phase disorder, in which the circadian rhythm cycle gets all messed up. They are not sleepy till 2 o'clock in the morning, and then they cannot wake up till 11 or 12. Well, so they go to school and they can't learn because they may be sitting there, but their brains are not awake. And the average adult needs between 7 and 8. As I said, I need 9. And if I have missed an hour for some reason, the plane was late or whatever, then I need a 15-minute nap in the afternoon, because a 15-minute nap can compensate for the loss of an hour's sleep the night before. You tend to fall asleep faster the more tired you are. And here's the problem with sleeping pills. They may initially help you to fall asleep, but it's a little bit like alcohol. Many people drink a glass of wine at night because they say it helps me fall asleep. But alcohol and sleeping pills often wake you up during the night. They do not keep you asleep. And the next day, you're never as alert anyway, because the sleeping pills are interfering with key housekeeping tasks and with key brain chemicals. For example, there's a medication that's used for allergies called Benadryl. You familiar with Benadryl? Well, one of the side effects of Benadryl, and many people use it as a sleeping aid, which is linked with a higher risk for dementia, Benadryl actually interferes with the production of a brain chemical called acetylcholine, which helps you be alert. So right on the medication it says, do not use this and use machinery or drive, because it's interfering with your alertness. So there's whole research projects now about what happens when you do that. The brain is 2% of your body weight, approximately, unless you're very obese, and then it can certainly go down. But it uses 20% of all the energy resources in your brain and body. Because remember, it uses 3 times as much energy as body muscles and 2 times the energy of other body cells. The brain does not store any oxygen. 8 to 10 seconds without enough coming through blood flow and you're going to be unconscious. It does not store glucose. So you need high quality food eaten at regular intervals so that there is a continuous supply coming to the brain. There's one exception, the glial cells, those, servants, whatever you want to call them, personal assistants. They store a little bit of glucose as glycogen, and in an emergency, if it's a real emergency, they can take that glycogen and reconvert it to glucose and keep the brain going a little bit longer. I mentioned, maybe not this afternoon yet, that body cells can use almost any kind of nutrition for energy, fats, proteins, carbohydrates. But brain cells, neurons, can only use glucose from carbohydrates. So now we're wondering what's going to happen to a person's brain in 25, 35, 45, 50 years who have been on very low carbohydrate diets. But there's lots of kinds of carbohydrates. You need high quality carbs, meaning coming from fruits and vegetables and preferably non-wheat ancient grains and so on. It's the best fuel for the brain cells. So I've already mentioned that without sleep you're going to die. There are a couple of really interesting syndromes where the brain refuses to go to sleep, and in some of them the person's dead in 3 or 4 months. You just cannot survive without sleep. Now, if you cut your sleep, then the likelihood is that the brain is not going to be able to do some of those critical housekeeping tasks, like removing the proteins that are not needed from the brain and toxins and so on. Be very clear that mental fatigue takes longer to recover from than physical fatigue. Totally different process. Now, what are some of the housekeeping chores that the brain needs to do in order to keep you staying younger and healthier for longer? It restores brain energy reserves. Okay, now you've got the ATP, and it's stored in the energy factories to some degree in each cell, and those little factories are called the mitochondria. So it replenishes that. It processes what's happened during the last, 16 to 24 hours, and it does that through dreaming. So dreaming can be very, very healthy for you, unless You've been staying up late at night watching scary movies, and now you wake up screaming and in a sweat because zombies are running after you and they're going to kill you. You know, got to be really careful what you put into the brain because it will come back to haunt you. It provides the brain with a special type of electrical stimulation that the next day is designed to help you learn quickly, remember what you learn, make good decisions, you know, have good thinking processes. And it's critical. It takes time to do that. It consolidates information. What does that mean? It means that it looks at everything you took in and learned during the day before you go to sleep, and it moves it, puts everything together that's alike, and moves it from short-term to long-term memory. It also repairs the cells in the hippocampus that is your search engine, so it can go to long-term memory and pull out what it is that was stored there that you want to remember. It helps maintain homeostasis, meaning the brain works best in balance. And as those housekeeping tasks get done, you rebalance your brain. It collects especially norepinephrine and serotonin, so it can be reused. The brain is very conserving of its chemicals. Do you understand what it means when the research says there's reuptake of norepinephrine and serotonin? Up and down means yes. Good, 15 seconds. When you want to move energy from one neuron to another, the information comes down to the end of the axon. You know, here's your hand, it's a neuron. The palm of your hand's the cell body. Here's the axon, the largest projection that takes information out of the cell and moves it to the next cell. And now you've got all these dendrites. You can grow a new dendrite in 30 minutes. You can change the shape of one in 30 seconds, depending on what you're doing. So when you think, the information comes down to the end of the axon where there's a lot of little tiny bulbs that contain neurotransmitters to take the information, swim it across the synapse, and let it go into the dendrite of another cell. We're learning, for example, that in a brain that is called retarded, brain challenged, they don't have enough, often they don't have enough dendrites. There aren't enough fingers to pull the information into the cell so they can get it into the cell ordinarily it's picked up with these dendrites, but there are not enough dendrites. You know, a healthy cell's got 10,000 fingers. So you can expose that brain to learning, but there's not enough dendrites to pull that information into the cell. And if you're lazy, the axon and the dendrites can start to shrink, and then you get, instead of a nice little tight synapse, it gets bigger and bigger and bigger, and those neurotransmitters just can't swim it across. But supposing everything goes well, energy, information down at the end of the axon, a neurotransmitter picks it up there, swims it across the canal, dumps it into the other neuron. Now, skin divers arrive, and they collect all of that neurotransmitter and take it back and put it in the storage bins at the end of the axon so that it's ready for the next time you want to think. It's an amazing system. And at night, one of the things the brain does is go around to the ends of the dendrites and collects all the norepinephrine and all of the serotonin, puts it back in these little storage bins so it's ready for you to think the next time. It's just Star Wars, I'll tell you. Let's see. It reduces your brain body temperature and lowers the level of your metabolic energy expenditures because it wants that energy to use to create new cells that divide and multiply and to